Section 5.5 Apply remainder and factor theorems. Our first example, we have our first polynomial divided by our second polynomial. The first thing we have to set up is the problem. We will use the same properties that are used in synthetic substitution. In each power after the highest power, each power needs to be represented by a number in the equation. In the first polynomial, there is no x squared. So to substitute for that, we will use 0. As you can see, the x squared is substituted by 0x squared. The first polynomial will go inside of the division problem, and the second polynomial will go outside. To begin your division problem, you look at the highest power. So 3x to the fourth power is the highest in this equation. So now you write 3x squared in the equation. You write it on top of x squared, since x squared times 3x squared equals 3x to the fourth power. You put them in line with the matching powers, so that is why the x squared is matched with x squared. To begin dividing, you get each outside number and multiply 3x squared. So 3x squared times x squared equals 3x to the fourth power, and 3x squared times negative 3x equals negative 9x to the third power, and 5 times 3x squared equals 15x to the second power. Now since you have 3x to the fourth power, they cancel each other out. And now you subtract each remaining number. So negative 5x to the third power minus 9x to the third power will give you 4x cubed. And x squared minus 15x squared will give you negative 15x to the second power. Now you drop down 4x. Now you will repeat your steps again. Now you look at your highest power again and think what will get you 4x to the third power. So your next number will be 4x, since 4x times x to the second power will get you your biggest number, 4x to the third power. So now you will multiply 4x by x squared, negative 3x, and 5. So 4x times x to the squared will give you 4x cubed, and 4x times negative 3x will give you negative 12x to the second power, and 4x times 5 will give you 20x. Now you are going to subtract again, and the x cubed terms will cancel each other out. And then 15x squared minus 12x squared will give you negative 3x squared. And 4x minus 20x will give you negative 16x. Now you will bring down negative 6 to your problem. Now you must look at your highest problem again, which is negative 3x squared, and think, what times x squared will get you negative 3x squared? And negative 3 will get you negative 3x squared, since negative 3 times x squared will get negative 3x squared. Now again, multiply negative 3 by each term up here. So negative 3 times x squared will get you negative 3x squared. And negative 3 times negative 3x will get you 9x. And negative 3 times 5 will get you negative 15. And now the x squared terms will cancel again. Negative 16x plus 9x will get you negative 25x. And 6 minus 15 will get you 9. Now this is your remainder. Now your answer will be this, which is 3x squared plus 4x plus your remainder, which is negative 25x plus 9 over the polynomial you divided by, which would be x squared minus 3x plus 5. So this right here would be your answer.
Our first example we have for synthetic division is a polynomial divided by another. First thing to do is to set up the problem. We will use the same properties as synthetic substitution. So set up the problem as you would synthetic substitution. The x plus 2 variable will be set to 0, and the end product is what we will use to divide it by the larger polynomial. So we're setting it to 0 right now. Subtract 2 from both sides. Your end product is negative 2. So now we're going to use this to divide this. Alright, so let's set it up. So we have negative 2, which still correlates with the x minus 2, divided by, since we're only going to use the first, since we're going to be using the first coefficients, we will use 1, negative 3, and negative 7 with positive 6. Synthetic division is really easy. First off, we have to drop this first variable always down to the front, where it will be multiplied by the negative 2. And then that product will go under this bar. So then we get negative 5 if we add these two together. Remember, you have to add these. So negative 5 times negative 2 is positive 10. Positive 10 plus negative 7 equals positive 3. Positive 3 times negative 2 equals negative 6, which cancels out this 6 right here. Now these are all going to be your coefficients for your end product. This end product is going to be a lesser power than the original polynomial, since we had, let's see, x to the third. Our new product is going to be x squared. The first term being a 1 denotes that it'll be x squared minus 5x plus 3, and since there's nothing in the last coefficient, then it'll be fine. There's nothing here. Now this next part is important, because if you happen to get no remainder, which means the last number is 0, then this means that x plus 2 is a factor of the polynomial. This is what the factor theorem is. We just used it for the last example. Polynomial f of x has a factor of x minus k if and only if f of k